Good morning everyone, myself Rajyalakshmi. Now I am going to discuss about the reactions of benzene. Before going to the top of the reactions of the benzene, now we will discuss about the what is meant by benzene. So that is nothing but one of the important aromatic compound which consisting of the closed ring which is comes under the category of the homocyclic compound. Why? Because which is composed with that of totally 6 carbon atoms. Those are which are further bonded with that of the 6 hydrogen atoms. And also which consisting of the 3 double bonds. Those are present alternate to one another. So, because of this conjugated yin system, that benzene ring which is showing the aromaticity. So, because of that it can able to undergo the electrophilic aromatic substitution reactions. So, which is the one of the most important chemical property of the benzene. So, coming to this, these are different kind of the reactions, that is halogenation, nitration, sulfonation, Friedel-Crafts alkylation and Friedel-Crafts acylation. So, all these are the different kind of the electrophilic aromatic substitution reactions. Now, we will discuss about the general reaction mechanism of the halogenation. So, all you know the structure of the benzene. So, where it consisting of the 6 carbon atoms which are further bonded with that of the 6 hydrogen atoms. So, here this benzene which is acting as a base. So, why? Because where there is a availability of the more number of pi electrons. What happens? These pi electrons, those are forming a pi cloud like this way. Half of the pi moiety that is present above the molecule, half of the moiety that is present below the plane of the molecule, forming a pi cloud. So, how it is formed? How means, if you observe the structure of the benzene, where it consisting of the one unhybridized p orbital at each carbon atom, which is present perpendicular to that of the plane of the molecule, in which that each of the unhybridized orbital carrying the one unpaired electron. So, these unpaired electrons, this will forms a pi moiety like this way. So, because of that which is rich in electrons, so that way it can be able to share their electrons with that of the electron deficient species. So, coming to that of the general reaction, when the benzene is treated with that of the acidic reagent, maybe it is composed with that of the electron deficient species and electron rich species, that is nothing but electrophile and nucleophile. So, what happens when the benzene interacts with that of the acidic reagent? In the presence of the suitable catalyst, it can able to form the electrophile substituted benzene. Electrophile substituted benzene. That is a general reaction. That means that what happens in the benzene ring, the one of the hydrogen atom is replaced by that of the electrophile. So, that way which is forming the electrophile substituted benzene. That is the general reaction. And next, coming to that of the reaction mechanism. That reaction proceeds in 3 different steps. First one is the formation of the electrophile. Second one is the attack of the electrophile onto that of the benzene ring. And last one is the formation of the product through the loss of the proton. Okay. So, coming to that of the step 1. What is that? That is formation of the electrophile. So, how it can be formed? When the acidic reagent interacts with that of the catalyst. So, what is the purpose of using this catalyst? So, that is nothing but that catalyst which enhances the rate of the reaction without changing its chemical nature, its structure. So at that time there is a release of the electron deficient species, what we are calling as electrophile. The so generated electrophile, when it comes in contact with that of the benzene, so at the time what happens, if you observe the structure of the benzene, where there is a availability of the pi electrons in the form of the 3 double bonds. So at the time what the benzene does, the pi electrons, those are present in the benzene, those are going to be shared between this electrophile. That means that it cleaves their one of the double bond and it converts their double bond into the new sigma bond. That is going to be converted into the new sigma bond, like that way. So at the time what happens here, there is a formation of the uranium ion. What it is? Developing the positive charge on the carbon of this aromatic ring. Okay. So which is the unstable one? Why? Because that is the intermediate in stage. So for getting the stability, it has to remove their or release their proton. So before releasing the proton, it will undergo the certain kind of the changes, that is because of the resonance. So that what we are calling as, that is going to resonance stabilized. So how it can be stabilized? The so formed uranium, that it can be stabilized by the delocalization of the pi electrons about to that of the ring system. So when there is a electron deficiency at the first carbon, what happens here? The adjacent pi electrons, those are present to the electron deficient, those will shift to that of the electron deficient carbon, like this way, forming the double bond between this 6th to 1st carbon, like this way. So when the pi electrons, those are present between 5th to 6th carbon atom, are shared between 6th to 1st carbon atom, at the time what happens? This 6th carbon taking the one of the pi electron that is present at the 5th carbon atom. So at that time what you observed here, there is electron deficiency at this 5th carbon atom. Further, the adjacent pi electrons to that of the 5th carbon are going to be shifted between this 4th to 5th carbon, like this way. So in this process, the 3rd carbon, it will become electron deficient. So all these are the resonance stabilized structures of this uranium intermediate ion. Okay. So which is the unstable. So once it interacted with that of the nucleophile attached catalyst, what happens here? That nucleophile, it abstracts the available proton. So where that 6 carbon atoms containing the 6 protons, but for the nucleophile it is very easy to abstract the proton which is already attached with that of the electrophile. Why? Because of the formation of the new bond of the new sigma bond with that of the electrophile. Here this sigma bond, the sigma bond which is present between 2nd carbon to that of the hydrogen atom, that is going to be weakened. That's why this nucleophile, it can readily abstract the proton. So that way this radium, that it can be stabilized into a stable product, what we call as electrophile substituted benzene. So that is the general reaction mechanism of the electrophilic aromatic substitution reaction of the benzene. So what are those? That is nothing but first one is the formation of electrophile, second one is the reaction with that of the benzene, and last one is the formation of the product through the loss of the proton. So coming to that of the energy diagram, so here which is the starting material, that is nothing but benzene. So when the benzene interacts with that of the electrophile, what happens? It will forms a uranium ion. The formation of the uranium ion is the typical reaction. That's why that is called as rate determining step. So once it forming a intermediate, so at the time it will readily quickly forms the product, so that it can be represented with this energy diagram. So next, coming to the some of the important electrophilic aromatic substitution reactions. So coming to the halogenation, for example, take the chlorination. When the benzene is treated with that of the chlorine in the presence of the ferric chloride, it can able to form the chlorobenzene along with the release of the HCl. What is that HCl? Here the one of the hydrogen of this benzene is replaced with that of the one of the halogen atom of the chlorine. So coming to the reaction mechanism, so what is that? First one is the generation of the electrophile. When the chlorine interacts with that of the Lewis acid catalyst like that of the ferric chloride, so at the time what happens? It can be able to release the electrophile. The so formed electrophile, that is going to be interact with that of the benzene, thereby forming a new sigma bond like this way. So at that time the benzene ring, that is going to develop a electron deficiency at this first carbon atom. So this electrophilic aromatic substitution takes place at any of this ring system, that is not limited to that of the second carbon. It may takes place either at first carbon, third, fourth, fifth, sixth, whatever it may be. For example, I am telling that that is going to attack at the ortho carbon or at the second carbon. Okay. So once it forming the reactive intermediate, so that is going to release the proton, so that way it can able to release the chlorobenzene with the regeneration of the catalyst. And next, coming to that of the nitration. When the benzene is treated with that of the concentrated nitric acid along with that of the sulfuric acid, and the reaction mixture heated at 60 degrees Celsius, so at the time it can able to undergo nitration, so that way it can able to form the nitrobenzene. That means that what happens here, the one of the proton of this benzene is replaced with that of the nitro group. Here this one of the proton is releasing that in the form of the water molecule. So coming to that of the reaction mechanism, that is generation of the electrophile. When the concentrated nitric acid treated with that of the 2 moles of the sulfuric acid, so at the time it can able to release the electrophile, that is nothing but the nitronium ion, and this sulfuric acid that is going to release in the form of the 2 moles of the bisulfate ion. So the electron deficient species that is going to be attracted with that of the base like that this benzene. So at the time that benzene that is going to share their electrons with that of the available electrophile. So that way it will form a new sigma bond with this carbon to that of the nitro group. Further release of their proton. So how it can be releasing? In the reaction mixture where there is availability of the bisulfate ion that is going to obstruct this proton. So that way that intermediate that it can be stabilized, so that way it can be converted into nitrobenzene. So here the sulfuric acid that is taken as a catalyst. And next coming to that of the sulfonation. So here the sulfonation can be done by two ways, either with that of the sulfur trioxide, or it can be done by using the fuming sulfuric acid. So fuming sulfuric acid means that is a combination of sulfur trioxide and the sulfuric acid. Okay. So first coming to that of the reaction mechanism, that is nothing but generation of the electrophile. So for example, we taken the example reaction with that of the fuming sulfuric acid, that is sulfur trioxide and the sulfuric acid. So at the time here the sulfur atom which is attached with that of the 3 electronegative atoms. So at the time what happens, any one of these oxygen atom that is going to obstruct the one of the proton of this sulfuric acid. So why? Because that acid can able to release their proton, nothing but upon the ionization of the acid it can able to release the proton. So at the time it can able to convert it into electrophile. Further the so formed electrophile that is going to interact with that of the benzene, and where this double bond that is going to be cleaved, and further that it can be converted into the new sigma bond like this way. And finally when the proton is abstracted by that of the available bisulfate ion, it can able to convert it into the benzene sulfonic acid. So here the proton along with that of the bisulfate ion that is going to release in the form of the sulfuric acid. And next coming to that of the Friedel-Crafts alkylation. So one of the important chemical property of the benzene. So coming to this, when the benzene is treated with that of the alkyl halides, that it may be methyl chloride, ethyl chloride, propyl chloride, whatever it may be, when it is treated with that of the alkyl halide in the presence of the suitable catalyst, at the time it can able to convert into the alkyl benzene. So coming to the example, when the benzene is treated with that of the methyl chloride in the presence of the aluminum chloride, so at the time that it can be converted into the methyl benzene, or otherwise commonly which is called as toluene. Coming to the reaction mechanism, the first one is the generation of electrophile. Okay. When the methyl chloride treated with that of the aluminum chloride, so that means that here that aluminum chloride which is acting as a catalyst. Okay. So at the time what happens, where the halogen atom of this methyl chloride that is going to interact with that of the Lewis acid, so that way leaving this methyl chloride as a methyl carbonium ion, the so generated electrophile that is going to react with that of the benzene, and thereby it can able to convert into a rhenium ion like this way. And finally the halogen atom that will abstract the proton where the methyl group is attached on this carbon atom, so that way it can able to convert into the methyl benzene or toluene with the release of the HCl. Okay. So when there is a presence of the very low number of hydrocarbons, it will simply forms a it will straight away forms the product. But when there is a consisting of the complex structure of the hydrocarbon, nothing but alkyl halide, so at that time it can be able to undergo rearrangement. It can be able to undergo rearrangement. So now we will discuss about the rearrangement of the benzene. For example, when the benzene is treated with that of the 1-chloropropane in the presence of the aluminum chloride, so at the time it can be able to convert into the isopropyl benzene. So actually what we think, if the benzene is going to react with that of the 1-chloropropane, that will give 1-propane benzene, but here in this case that is not happening. Instead of forming the 1-propane benzene, which is forming the isopropyl benzene. Why it is forming isopropyl benzene? What is the reason behind that? So coming to the reaction mechanism, so as usually there is a generation of the electrophile, so that it can be formed by the interaction with that of the alkyl halide, nothing but 1-chloropropane when it is treated with that of the aluminum chloride. So that way it can be able to form the primary carbocation. So why we are calling as primary carbocation? So if you observe the 3 carbon atoms, that first carbon atom is showing the electron deficiency, that is attached with only one alkyl group, it containing remaining 2 hydrogen atoms. So that's why that is the primary carbocation. If we observe the structure of the primary carbocation, where it consisting of the 2 more carbons. So when there is a electron deficiency observed at the first carbon, if the structure is permitting, at the time the adjacent hydrocarbons, those are present to that of the electron deficient carbon, those can be shifted onto this carbon, electron deficient carbon. So at the time what happens, that CH2 it will become converts into CH3, leaving this second carbon as electron deficient. So why we are calling as this which is a secondary carbocation? Why? Because that electron deficient carbon that is attached with 2 alkyl groups. So that's why that is calling as secondary carbocation. So here what happening when there is a structure permits, at that time it can able to undergo rearrangement. Why it has to undergo rearrangement? Why? Because for the formation of more stable carbocation. For the formation of more stable carbocation. So that is the reason. If it is able to forming the more stable carbocation, it will readily forms the product. So that's why that with the help of the secondary carbocation, that benzene going to form a isopropyl benzene instead of forming the propyl benzene. That is the reason. So which is the one of the important reaction, that is the rearrangement of the benzene. Okay. And next coming to that of the Friedel-Crafts acylation. Coming to this reaction, that is nothing but when the benzene is treated with that of the acetyl chloride or acetic anhydride in the presence of the suitable catalyst like that of the aluminum chloride. So at the time what happens, it can able to give the aromatic ketones. It can able to convert into the aromatic ketones. For example, if you observe the reaction, when the benzene is treated with that of the acetyl chloride in the presence of the aluminum chloride, so at the time what happens, here one of the hydrogen is going to replace with that of the this acetyl moiety. So that way it can able to convert into acetophenone. acetophenone. So coming to that of the reaction mechanism, first one is the generation of the electrophile. How it can be generated? When the acetyl fluoride treated with that of the Lewis acid or in the presence of the Lewis acid, it can be able to release the acetyl carbocation. Further, that is going to interact with that of the benzene. Why? Because there is availability of the pi electrons. So that way it can be able to form a new bond, new sigma bond with this second carbon atom, forming a intermediate like this way, and this intermediate that it can be stabilized through the release of the proton where the acetyl moiety is attached. So that way it can be able to form the stable product what we call as acetyl benzene or acetophenone. Thank you very much. Thank you for the patience listening. Thank you.